Continuing our notes for using CPCTC and overlapping triangles, we move on to another proof here. This was one where we have sort of this bow tie picture going on that is very, very common for us to use. For some reason, we get a lot of this typo here where it has an R where it should be an angle marking. That should be angle D and angle C on this proof here. So there we go. That's fixed now. They marked angle D congruent to angle C in the picture. They've marked A, B, and EB. Let's strategize before we write our proof here. There is this bow tie picture, so we've got these vertical angles in the middle that can be congruent. Then that would give us enough to prove the triangle's congruent by angle, angle, side. And then we can say the last statement by CPCTC. So let's get that into our proof. So D and C was given. We also had a segment AB and segment EB as given. Then we had said that angle ABD is congruent to angle, I'm going to say EBC. I like to name them kind of like I would if it was a congruent triangle. Vertical angles congruent for the reason, again, be sure you put congruent or vertical angles postulate. Just vertical angles that would be marked wrong there. Be very careful. All right, so I've got my three pieces to show my triangles are congruent. Now I can name them. I'm going to say ABD. Started with A with no marking, then to B with 2, and then to D with 1. So start with no marking at E, then go to 2 at B, and then to 1 at C, just to match the order of the way I named it. And we said that that was going to be angle, angle, side, because it was two angles and the side that's not between them. That one is the theorem. Angle, angle, side, and HL are the ones that are theorem. All the others are postulate. And then my last statement is that DB is congruent to CB. Those are pieces of these triangles. So corresponding parts of congruent triangles are congruent. CPCTC for my reason on that one. On this next one, we've got parallel lines. I can tell they're parallel because these little arrow markings. And again, we have a little bit of a typo in here. This, where it's a P, should be the parallel symbol. They marked it right in the picture, but had that typo there. We've also got marked MQ congruent to TN that are already marked in the picture. These triangles are touching triangles. Just to kind of think ahead for my proof here, they share the side in the middle. So that's going to be a reflexive property for that reason. And remember that when they give you parallel lines, please use them to find angles that are congruent. In this one, I've got alternate interior angles at the top at M and on the bottom at T there. So I'm going to use those alternate interior angles congruent in my proof. Once I have that in my proof, I can use side angle side to show that the triangles are congruent, and then CPCTC for my reason at the end. So starting out MQ parallel to TN, and I'm going to see if I can also fit MQ congruent to TN. There we go, it fit in one line. Given, you can put all your givens together. Then you could either use the reflexive, that was the second thing I noticed, or you can use the angles. It really doesn't matter. I'm going to go to the angles just because the parallel lines are right here. So I'm going to say that angle QMT is congruent to angle NTM. And if lines parallel, then alternate interior angles congruent there for my reason. And I put that second just because the parallel lines were right above it. Now I'm going to put my reflexive property statement in here, which is that MT is congruent to MT by the reflexive property of congruence. And now I have the three parts that I needed to say my triangles are congruent. So I'm going to name them. First one doesn't matter how you name it. I'm going to say NTM. I started at N, which was kind of out here with nothing on it, so I'm going to start at Q, which is matching with that, kind of out here with nothing on it. I went to T, which had one marking, so I have to go from Q to M because M has one marking in that triangle, and then over to T. And the reason for that was side angle, side congruence postulate. Hopefully we're feeling good about naming those by now, like which theorem is which. And then my last statement is that MN and TQ will be congruent by CPCTC. Corresponding parts of congruent triangles are congruent for the reason at the end there again. The next one has some overlapping triangles. It says overlapping triangles are triangles that share either a side or an angle. These parts are usually used to prove the two triangles congruent. The reason for an overlapping statement is the reflexive property. So they overlap triangles to try and hide information from you. So you have to visualize what are they sharing and see how that's going to help you with your proof. In here it says, what are the overlapping triangles in each of the following, and what is the side or angle that they share? Are they congruent, and what postulate or theorem justifies your answer? So right here, they share this piece GH. So they share GH. And if you visualize them separately, you can see NHK is one triangle. And I'm going to start my congruence statement. And so I said NHK started at the right angle, so I'm going to start at T. I went to H. That should be from T to G, and then up to M. So let me see. I already wrote they're congruent. Let's figure out why they're congruent. If they share the GH piece, then from G to T is the same as it would be from N to H. And so that is a side that they have in common. They also have two angles marked. The side that they have that's congruent to each other is not between those angles. So this is going to be angle, angle, side instead of angle, side, angle. If it was this side here from K to N, then it would be angle, side, angle. So this one, the reason is angle, angle, side, because the side is not in between. And that is the congruence theorem. This next one I drew so that I could separate them for you. There's a lot of triangles in this picture, and depending on what you're looking at, you could be saying different things. So we wanted them to overlap, so notice that they like share this triangle in the middle, sort of. And they have ED, this segment is overlapping there. And so I would say they share segment ED. And I'm just going to pull those triangles apart so we can visualize them. And they shared from E to D, which is kind of this part of the bottom segment. And in this one, it's from here to here. So they shared that piece, and then this congruent piece here, if you add those together with segment addition, you would see that that entire side from A to D is the same as it is from E to C. So you do have those sides congruent, and then you can see they already had congruent markings on the angles that surround that side. So our reason is going to be angle, side, angle, because the angle is between them, and that's the congruence postulate. And to name my triangles, I've got ABD up here in green. I started with A with 1 mark, to no marks, to 2 marks. So start at C with 1 mark, so triangle, don't forget to put that triangle in there. So I went from 1 to none to 2, 1 to none to 2 would be C to B to E for my statement there. And it's, sometimes it's hard to see them. You got to really get used to it. You got to draw them separate from each other to help yourself visualize things. That really does help. On this next one, again, I drew them so I could separate them. I've got the purple one and the teal one. And they have a shared side, which is KM. They share KM. That's the overlapped part, so mark KM in each of them. And now you can see that they have two angles marked and the side is not between those angles, so it's going to be angle, angle, side, and they both have that same kind of angle, angle, side marking going on. And we're going to name them. I'm going to say LMK. Remember that the first one, the order doesn't really matter. So I started at L with 1 to 2 to none. So I got to go from 1 to 2 to none. So NKM in the name. And then we had said that that was going to be angle, angle, side congruence theorem for the reason. Here's another one with overlapping. And this is going to be the last one I'm going to do in the notes, and I'm going to ask that you do the next page, try it by yourself, and check it with me in class. So in this picture, I have the blue triangle, and I have the green triangle, and I don't know why it just keeps clicking that, and there we go. Try to get that blue border away. All right, so in these triangles, look at them when they're drawn together. They share an angle, and finding the shared side is a lot easier, in my opinion, than finding the shared angle for some reason. That's harder to see for me, so just notice how they share W. W is the same for both of them. They've already used one arc, so I'm using two. So I'm going to mark these angles at W congruent to each other because they share that. And now you can see in my pictures where they're separate, you can see that there's two angles on the side that's not between them. So it's going to be angle, angle, side, and they both have that same kind of marking. So I am going to use angle, angle, side congruence theorem to say why they are congruent, and now I just need to name them. I'm going to say ZWU. So I went from 1 to 2 to none. So over here, match that 1 to 2 to none. So triangle XWV for naming that one to match the first. And then like I said, I want you to look at this next page by yourself. I want you to try it out, draw them separate, figure out what they share, figure out why you think they're congruent, name the triangles, and I want you to check that with me in class.